Hello to the Minnesota Ornithologists Union. This is Lee Frelich, Director of the University of Minnesota Center for Forest Ecology, and thank you for inviting me to give this presentation on climate change in forest and the alternative futures which we face according to the future climate change scenarios, which I will get into in a minute here. First, however, I wanted to show some of the previous scientists who were important in climate change. Fourier, for example, discovered that greenhouse gases exist way back in the 1820s, so we're almost to the 200-year anniversary of the discovery of greenhouse gases. Tyndall showed that they play a role in the historical changes of climate on the Earth. Dr. Seuss here, probably not the Dr. Seuss you're thinking of. This is Dr. Hans Seuss, who was an atmospheric chemist who showed that the excess CO2 in the atmosphere does indeed come from fossil fuels because it has a different isotopic signature than CO2 coming from other sources like volcanoes or the oceans. And he showed that way back in the 1950s. And then there's the really big player here, the Swedish scientist Arrhenius. You all know Arrhenius because you learned that reactions go faster at high temperatures than low temperatures when you were in 8th grade science, and you also learned that dissolved salt in water conducts electricity. And those were Arrhenius's findings, but he was also very interested in climate change, and he spent 2 years doing calculations with paper and pencil that showed how much the Earth would warm up if we doubled the CO2 content of the atmosphere, and that was published in 1896. So it's been since that time that we've known that we would have a large magnitude of warming. He predicted 4 to 6 degrees Celsius, which is on the upper range of the same calculations that we do today, but nevertheless his predictions still stand. And why do scientists think global warming is so important? Well, the biggest reason is that the largest mass extinction in the Earth's history, the end Permian extinction, was caused by an episode of global warming due to rising CO2. In that case, it was due to volcanoes and the resulting acidification of the ocean and loss of oxygen, and then the knock-on effects of hydrogen sulfide coming out of the ocean and poisoning life on land, combined with the warmer temperatures, resulting in mass extinction all around the planet. In fact, of the 5 great mass extinctions in the history of the Earth, 4 of them were associated with rising CO2 levels. It's just that this time humans are the volcano, and we are changing the CO2 content of the atmosphere. So a low CO2 emission scenario, which is what I hope we end up following, minimizes the chances of surprises or tipping points in the Earth's climate. So there are these tipping points, like the Boreal forest, for example, between northern Minnesota and Edmonton, Alberta. If that forest were to die because of a warming climate, all the carbon in that forest, which is an area twice the size of California, would go into the atmosphere and reinforce the warming. There are many other tipping points around the world that could cause the Earth to suddenly go into a hothouse condition, where it would be as much as 8 to 12 degrees Celsius warmer than it is now. The only way to be sure we don't trip one of these tipping points is to have a scenario that stops at maybe 2 degrees Celsius warming. I think if we go on to 4 degrees Celsius warming, probably we will trip one of these tipping points, and then the warming will accelerate on its own regardless of what people do. So I think it's very important to minimize emissions of carbon dioxide, to switch to renewable energy as fast as possible, and reduce the use of energy through conservation and other measures. So here is some evidence of how forests have responded in the past to climate change. These are trees in the Yamalia region in the northern Urals in Russia. They're right at the northern edge of where trees can grow, right at the edge of the Arctic tundra. And as you can see in the graph here, which goes back 2,000 years, that they are growing more now, if you look on the very right side of the graph, than they have in the last 2,000 years. And that's because warm temperature is the limiting factor for them, and it's been warmer in the last few decades than it has for 2,000 years. So trees are very good witnesses. They record these changes in climate in their tree rings, and they don't lie either. So you can interview a tree and you can be pretty sure it's going to tell the truth through the structure of its rings and the shape of the tree and all sorts of things. They record events throughout their life in many ways. Here's a graph that shows climate change over the last 10,000 years, and it's a compilation of many different ways of measuring climate: ice core data, tree ring data, fossil pollen from sediments in lakes and bogs. And basically it shows in the middle there the warmest part, which was 6,000 or 7,000 years ago in Minnesota. That was the peak of the interglacial that we are in at this time. So it warmed up quite rapidly. It stayed fairly warm for a few thousand years, and then the interglacial started to come to its natural end, and for the last 5,000 years it's been getting cooler. This is all related to the orbital parameters of the Earth, these cycles in glaciers that tend to be 100,000-year cycles. And so we were back on a cooling trend, and then you see the red line on the right side there, and that is the warming we've experienced in the last few decades. So we're now warmer than on this planet than it was at the middle of the Holocene, which was the peak of the interglacial there about 6,000 or 7,000 years ago. And then here's the last 140 years since 1880. This is the length of the instrumental record. So as of 1880, there were enough weather stations with thermometers around the world that you could get a good world average temperature. And it just shows global average annual temperatures, and you can see it rising very steeply in the last few decades. Currently, our carbon dioxide level is above 410 parts per million. That's the highest in about 3 million years. And here's a graph showing the last 800,000 years, and it shows carbon dioxide concentration, and you see those ups and downs there about every 100,000 years. Those are those glacial cycles, and we had just seen a couple slides ago just one little part of the latest cycle. But you can see that whenever CO2 is high, it was an interglacial, and when CO2 is low, it's a glacial cycle, and glaciers are at their maximum. Then when you look over on the right side there, you see where we are now. We're a little higher than the 2008 blue dot there. But where are we going is the more important question. Are we going for a low emission scenario up above 500 parts per million carbon dioxide, or are we going on the high emission or business as usual scenario at 900 parts per million, which would literally take us back to having the chemistry of the atmosphere be what it was at the time of the dinosaurs. So two very different scenarios for the remainder of this century. And here's how the temperature distributions would work out for those two scenarios. And you can see on the left there the business as usual scenario, with the dark orange colors in our area being 7 or 8 degrees Celsius warmer than they are now, or than they were just a couple of decades ago. I guess the base time period is from the 1970s to the 1990s. And then you see on the right there the reduced emission scenario. It would only warm up about 2 degrees Celsius in this part of the world. So how would that influence Minnesota? Now that we've looked at the globe as a whole, let's zoom in on Minnesota. We have 3 biomes here: maple, spruce, or savanna. Well, the maple is the light green that kind of runs from the northern part of the state on a diagonal stripe down through the central and into the southeast. That's the deciduous forest biome with oak, maple, basswood, and cherry and hickory and those all those deciduous tree species. The dark green is the boreal forest that has the conifers like spruce and fir and jack pine. Boreal forests are the coldest forests on the planet, so they lie just to the south of the Arctic tundra, but they lie just to the north of either grasslands or temperate forests, depending exactly where you are in longitude. So northeastern Minnesota is boreal. It's our little slice of the boreal that's like what you find up in Canada or even in central Alaska. Has some similarities to Minnesota. And then finally we have the that yellow to beige color, the prairies in the western part of the state and kind of bending over toward the south central part of the state. Still grassland today, but except it's corn mostly instead of prairie, since we have very little natural prairie remaining. Very interesting place, though. There are only 2 other places on the entire planet like this. One is Kazakhstan, where these 3 biomes come together, and the other, although it's hard to tell because there's so little natural vegetation left, is in northeastern China, where you have boreal forest, temperate forest, and grasslands come together in one place. And here is boreal forest to show you what each of these biomes looks like. This is the Tetagouche State Park on the north shore of Lake Superior, and what you see in the picture are balsam fir and white spruce trees. And here is a picture of a temperate deciduous forest. This is to the south of the Twin Cities, the Cannon River Wilderness area. Mostly sugar maple in this picture, a few red oak, and many, many plant species on the forest floor that live in these forests. And here's a prairie, Mound Spring Prairie, with the open grasslands, a few shrubs, a few groves of trees here and there. And each of these 3 biomes has several hundred plant species associated with it, has its own plant pollinator network with hundreds of pollinator species, and supports a unique array of wildlife species, including a unique set of bird species. And so how do we expect the temperatures to change in Minnesota? Well, I've shown summer temperature here. JJA means June, July, and August, mean temperature. And you can see in the left here, right now, how warm it is, and then you can see the middle of the century and the end of the century. So, how much difference would there be for the high emission scenario versus the low emission scenario? Low emission being at least an 80% reduction in fossil fuel burning, so going to electric cars, conservation of energy, more efficient heating, and so on, and using sources of power like solar and wind to power things rather than fossil fuels. The key thing is to look on the right side there, the 2070 to 2099. What is the difference between the low emission scenario where we cut emissions by at least 80% by the year 2050 versus the business as usual where we do nothing, just keep going on as we are now. And you look at there, the upper one there, and you see that we're about 13 degrees warmer than we are now. This one happens to be in Fahrenheit because Don Wubbles and I use this slide in Washington, D.C., and they don't have Celsius in Washington, D.C., so this one happens to be calibrated in Fahrenheit. So 13 degrees warmer in June, July, and August, and that would make us about the same as a small town called Manhattan, Kansas is today. It's a town maybe an hour's drive to the west of Kansas City. On the other hand, you look at the low emission scenario, and we're about 5 degrees Fahrenheit warmer by the end of the century, and that would make the Twin Cities about the same as Des Moines, Iowa is today. So you can take your pick. Do you want Des Moines or do you want the middle of Kansas for the future climate of Minnesota? And we'll see what the implications of that are as we move forward here. One implication is that as it warms, the ranges of trees will move north, and we think that tree ranges, geographic ranges, would move north about 300 miles for the business as usual scenario by the end of this century. So this slide shows on the left side balsam fir, and the bright colors there, the bright red, that's where balsam fir is very abundant. The blue line shows the very southern edge of its range, beyond which it doesn't grow. So the lower map shows what it would look like for the high warming scenario, and essentially balsam fir would exit the state. It would move north by 300 miles, so the southern edge of its range would be beyond the northern edge of Minnesota. Very similar results would occur for other species like black spruce, white spruce, and paper birch. So that's one implication. Tree ranges will move north. We have a lot of tree range limits in Minnesota. Minnesota is an incredibly edgy state with all those biome edges, and virtually all of our tree species have range edges in Minnesota as well. The only exceptions, as far as I know, being cottonwood, green ash, and bur oak. I think all the other tree species we have either the northern edge of the range or the southern edge of the range in Minnesota, so they would change a lot in a warming climate. So here are some of the tree species of the boundary waters, the Boreal forest in northern Minnesota. In the upper left you have black spruce. The left middle is red pine. The lower left is jack pine. Right in the middle we have paper birch. The lower middle is balsam fir. And we have white spruce on the upper right and quaking aspen on the lower right. So that is a suite of boreal tree species. And how about switching these in the boundary waters for these species of trees in a warmer climate for the business as usual scenario, things like bur oak in the upper left there, or hackberry in the lower left, the elms across the bottom. American elm, red elm, and rock elm are our three native elms in Minnesota. Kentucky coffee tree right in the middle there, and then we've got basswood on the upper right and bitternut hickory in the middle right. In addition to sugar maple, red maple, things like red oak. So these are all temperate biome species that could move into the boreal forest in northern Minnesota. So I had a student who studied the interactions between these two groups of species, the temperate species, especially maple, oak, and basswood, and the boreal species, especially spruce and fir, at all of these locations. His name is Nick Fisichella. He graduated with a PhD several years ago, and he's now at Acadia National Park in Maine. And he visited all these black stars and red triangle sites, and the ones toward the north are right at the northern edge of the range for the temperate species. So there's a little bit of maple and oak mixed with a lot of spruce and fir, and then as you move to the south or to the southwest, out to Bemidji, which has warmer summers, it's mostly maple and oak and just a little bit of spruce fir. But all of these sites had both boreal and temperate species growing together right next to each other. And he looked at the growth rates of the saplings, and these would be from 3 to 7 or 8 feet tall on the forest floor. They represent the future canopy. when the upper canopy trees that are there now eventually die. So looking at balsam, fir, white spruce, red and sugar maple, and red oak, measured their ring widths and their height growth. And this is what he found when you move along that summer temperature gradient for June, July, and August. In the cool summer areas, fir and spruce grow more than maple and oak. And right in the middle, there's a crossover point where boreal and temperate species grow about the same amount. And then on the right, when you get into the warmer summer temperatures, the temperate trees grow faster than the boreal species. So if you look at a place like Duluth or Ely, which had very cool summers from 1960 to 1990, which is a baseline period we use for a lot of analyses, fir and spruce clearly grew more than the temperate species. And in recent years, they've been right near that crossover point. And in just a few years in the future, if it continues to warm, the temperate species will outgrow the boreal species and therefore replace them. Here's a place in Wisconsin, Newport State Park. It's on Lake Michigan. And I visited this place in 1979. At that point, it was pure boreal. There was nothing but balsam, fir, white spruce, northern white cedar. I revisited that spot in 2016, and there on the right side is a sugar maple tree. Has invaded this boreal forest, and it's growing at about the same rate as the fir trees. So the little bit of warming we've already had is already making a difference in terms of temperate trees invading the southernmost part of the boreal forest. So the overall findings of Nick Fisichella studies is that temperate trees are invading boreal forest in places where the two forest types are close to each other. Maple and oak are moving into the understory of the boreal forest. They haven't been there long enough to replace the boreal species, and it's not yet hot enough to kill the boreal trees directly. So the zone of mixed forest is getting wider at this point, but it's inevitable if it continues to warm that the temperate forest will replace the boreal forest. We get big windstorms in Minnesota, and they will interact with climate change. We expect more big windstorms with a warmer climate, but they also affect the rate at which the forest can change, potentially from boreal to temperate. So these are pictures here before and after the 1999 blowdown, called the Big Blowdown of July 4th, 1999. And if you look at the after blowdown picture on the right, you see there's a lot of green there. Even though the big trees have been knocked down, the birch and aspen and pines have been knocked down, it still looks green. And that green is the balsam fir trees and spruce trees that were on the forest floor waiting to replace the big trees when they died. So the big trees blew down. They were boreal species, and they are being replaced by boreal species. It's still a boreal forest. It just has smaller trees because the big ones are blown down. If you look in northern Minnesota now, however, you'll find a lot of areas with red maple in the understory shown in this picture. The red that you see there is composed of red maple seedlings that have come into the understory of this boreal forest. So if this forest were to blow down in a big windstorm, it would instantly be converted to a temperate forest of maple. So that is the interaction there. More windstorms in a warming climate, accelerating the pace at which forests are converted from boreal to temperate. Now let's look at the prairie forest border. So on the left, you see the original prairie and forest of the state at the time of European settlement in Minnesota. So I had another PhD student, Nick Dons, who's now on the faculty at the University of Wisconsin-Superior, and he studied why was the prairie forest border in that location. And what he found was that it depends on the climatic water balance. So if you look at the map on the right, the brown areas are areas where the amount of precipitation is slightly less, is about equal or slightly less than the evaporation. So there's a net deficit of water in an average year. Whereas you look to a little bit further to the right in the green and blue areas, those are areas where there's an excess of rainfall over evaporation throughout the year. So and those areas support forests. And so that's why the prairie forest border lies where it does, or where it did at the time here in the late 1800s, at the time of European settlement. And the question is, where is that zero water balance that determines the difference between grassland and forest going to go if we are on the high emission scenario and it warms up by 13 degrees Fahrenheit in June, July, and August? Evaporation will go up tremendously. Well, we'll see in a minute here. First, however, I wanted to also make the point that with a warming climate, not only do we have the windstorms like I showed a minute ago, but also droughts become more frequent, insect infestations because trees under heat and drought stress can't defend themselves, and fires will also occur more often, and that will help to drive the change forward in addition to the change caused by temperature alone. And you may also remember the spring of 2012 when it got up into the mid 80s in Minnesota for over a week in the middle of March. So students who went to Florida for spring break that year experienced cooler temperatures than we had in Minnesota. It was like 85 on campus in St. Paul. Magnolias were in bloom. I never thought I would see magnolias bloom in March in Minnesota, but they did. And this pattern where the jet stream has these huge deviations north and south are becoming more common in a warming climate, and these extreme warm events could easily also accelerate the rate of change in forests. And you see there in the map in the upper part that red zone, which is where very warm temperatures made it almost up to Hudson's Bay in March. And what did that do to the forest? Well, here you see what we call phenological disturbance. So phenology is the timing of natural events, as I'm sure most of you know, when trees leaf out, when birds arrive in the spring, and so on. So the upper picture shows jack pine and balsam fir trees that have turned brown, and winter browning of white spruce near Thunder Bay, Ontario in the lower picture. And what happened is the trees came out of dormancy in March, which is way too early, and then experienced colder temperatures later on, and their foliage basically couldn't withstand that cold. And ironically, boreal tree species were killed by the cold because they woke up too early. The thing about this type of event is it will occur more and more often with a warming climate, and in fact, an average spring for the high emission scenario by the year 2095 would be like the spring of 2012. So it's kind of a time machine that gives us a view into the future. These trees did recover because they have stored energy in their root system. They grew new needles and so on. However, if this were to occur twice in a row, 2 springs in a row, they would exhaust their energy and they would be killed, and an event like that could potentially, in one fell swoop, wipe out the boreal forest from Minnesota all the way out to Labrador. And with the business as usual scenario, that will happen sometime between now and 2095. So let's go back to the information I showed you a few slides ago about the climate and how it relates to Minnesota's biomes, and I showed you how we have temperate forest if mean summer temperature is above 66 degrees, and if it's below 62 degrees we get boreal forest. And it's mixed forest where the spruce and fir and maple are mixed together in between. And then the climatic moisture index, precipitation minus potential evapotranspiration. If that's about 0, you're right in the prairie forest border. If you have a deficit of 2 inches or more, you're into prairie. And if you have a surplus of 2 inches or more, you're definitely into forest. So what happens if you map that? You map it now, and you map it using our projections for what the climate would be like for the low and high emission scenario in the future. Well, that is on the next slide. So look at the map on the left here. That is our current biome distribution. Notice we've got a little bit of the blue in northeastern Minnesota, which is boreal forest, and then kind of that light minty green would be the mixed boreal and temperate forest, and then the beige color there would be the broadleaf forest, which is the temperate deciduous, your maple, oak, basswood, hickory, and so on, and then the brown of the prairie along the western margin of the state. Notice the prairies actually moved off to the west compared to the map I showed you, the historic map at the time of European settlement. That's because it's gotten wetter in recent decades, but it hasn't warmed up enough yet to raise the evaporation rates. So we have more of a tree climate in southwestern Minnesota and Iowa now than we did at the time of European settlement. So the early phase of global warming actually made us wetter and pushed prairie climate off to the west. And that's one reason why it's so hard to maintain the prairie remnants we have now, because you're fighting the invasion of trees all the time, because it's now a climate that favors trees. Anyway, let's look at the future here, the year 2070. And here's a low emission scenario in the upper right. And you can see there's still some boreal in northeastern Minnesota. Mixed forest is still there, but it's pushed 50 to 75 miles further north. Lots and lots of the temperate broadleaf or temperate deciduous forest, and the prairies pushing a little bit further into the western part of the state than the current biome map. It's still recognizable as Minnesota, though. But look at the high emission scenario in the year 2070 in the lower right. And you see that now the boreal is totally gone from Minnesota, and that's 1/3 of all our biodiversity, plants, insects, animals, birds, everything gone from the state. Little bit of temperate deciduous in the northeastern part of the state, which would be mostly oak with some maple. Little bit of temperate deciduous forest sticks around in southeastern Minnesota because the big hills there create microclimates, and the north sides of the hills, for example, might still be cool enough to have some temperate forest, but look at the huge intrusion of prairie covering 90% of the state there. And this is the basis of my famous, or should I say infamous, quote that appeared in the Washington Post in April, where I said that we have a perfectly good Kansas now. We don't need a second Kansas in Minnesota. So that was based on this map. So hopefully we will be able to achieve the low emission scenario and keep Minnesota looking like Minnesota. So those are our alternative futures, depending on high or low carbon dioxide emission scenarios. We can look at this in pictures as well. We can find a climate analog for a northerly location, go to that place that right now has a climate like the northerly location might have several decades from now, see what the vegetation there is like. So the blue star is the boundary waters, and right now the area at the orange star near Granite Falls, Minnesota, has a climate like the boundary waters will have by the year 2070. So let's look at those two areas. So here's the boundary waters, 2.8 billion year old granitic type of rock here, mostly black spruce trees in this picture. So this is a genuine boreal forest. So what happens when you look at an area that is pretty much the same physiographically, similar rocks, similar soils, everything similar, the only difference being 8 degrees Fahrenheit warmer in summer. And here is that. Nice outcrops natural area, which is right next to the city of Granite Falls, Minnesota. And you see oak trees here, and you see patches of prairie within. So it's in the prairie-forest border type of climate. So again, that difference in the last picture and this one, the only difference is 8 degrees Fahrenheit summer temperature. And of course, if you change the vegetation or you change the biome, you change the wildlife species. So lynx get replaced by bobcat in the boreal forest of northern Minnesota. If the climate warms, moose get replaced by deer. Those two changes are already happening. There are many, many bird species that I could have chosen. But I chose one of my favorite, the black-backed woodpecker, which I see quite often in the boundary waters, and could be replaced by red-bellied woodpecker in the future, although last time I was at the Hubachek Wilderness Research Center near Ely, I was talking about this with the naturalist there, and she said red-bellied woodpeckers have already showed up in Ely, and I was really surprised by that. Of course, birds can fly, right? So they can respond to a warming climate a lot faster than trees. And I'll leave you with this slide. And it has a picture here by my friend David Luke, who's a professor of photography at one of the community colleges in the metro area. And he took pictures of iconic scenes in the boundary waters and then digitally altered them to insert pictures taken in southwestern Minnesota with prairies and oak trees. So here you see the boreal forest that exists there right now reflected in the water. And he digitally erased that above the water line and put in a picture of a prairie with an oak tree in it. So you have an oak savanna being reflected as a boreal forest there, and you can see the spires of the fir and spruce trees in the water there. Also like to thank the National Park Service, the Environmental and Natural Resources Trust Fund, and all of the people listed here for their funding and for their help with this research, and I look forward to taking your questions later on. So again, thank you for inviting me to give this presentation.